Hello, this is Mr. Collier, and today we're looking at Rolle's theorem and the mean value theorem. So firstly, Rolle's theorem basically states that if you've got a continuous and differentiable function on interval from a to b, and if, now this is a typo, if f of a equals f of b, like we have in this situation right here, then at some point between a and b, the derivative has to be equal to 0. In other words, there has to be a turning point. Okay, so that's what Rolle's theorem states. It's kind of common sense. If I've got a function and between one point and another point where the y values are equal, there's got to be some turning point where the derivative is equal to 0. And the mean value theorem states also if we have a continuous and differentiable function from a to b, then there exists a number c between a and b such that the derivative at c equals f of b minus f of a over b minus a. So if you look at this sketch of a function right here, then we draw the secant line, which is just a straight line drawn from a to b, and the slope of that line is, well, it's right here, f of b minus f of a is the rise, and the run is b minus a. Okay, so that's the slope of the secant line, which equals the slope of this tangent, which is the derivative at c. Okay, so we're going to use these now to solve some problems. First one, consider this function on the open interval from 1 to 9. Find all values c in this interval at which the conclusion of the mean value theorem is true. For any resulting value, verify it by graphing. Okay, so firstly, because it's continuous and differentiable on 1 to 9, I'm going to write that down. Since f of x is continuous on 1 is less than or equal to x is less than or equal to 9, and is differentiable on 1 less than x less than 9, by the mean value theorem, there exists a c in the open interval 1 to 9 such that f prime of c equals f of b minus f of a over b minus a. Okay, where those are the endpoints here. Okay, so we have f prime of c equals, now f of 9 is going to be 5, and f of 1 is going to be negative 3, so you're going to have minus negative 3, and we've got b minus a is going to be 8. So we've got 8 over 8, which equals 1. Okay, and the derivative of the function is going to be 9 over x squared, or 9 over c squared I should say, because it's evaluated at c. So we got this little equation that we can solve now. So c squared equals 9. C equals positive negative 3, but we're looking in this range, so c equals 3 is that particular point. Okay, next we're going to use the mean value theorem to prove that sine a minus sine b is less than or equal to absolute value of a minus b. Okay, we're going to start by letting x equal, or f of x, the function equals sine of x, and use mean value theorem. You notice you're going to get something like that looks like this. So we know this is continuous, okay, since f of x is continuous and differentiable everywhere. By MVT, the mean value theorem, there exists c in a, b such that f prime of c equals f of b minus f of a over b minus a. Okay, so the derivative is actually cosine, so I'm going to say cosine c equals, and we're going to get sine b minus sine a over b minus a. Okay, now notice cosine, actually first I'm going to conclude from that absolute value, we need some absolute value signs eventually. Absolute value of c is equal to absolute value of sine b minus sine a over b minus a. Okay, so if they're equal, then certainly the absolute values are going to be equal. So notice that cosine c, or let's say the absolute value of cosine c now, that is definitely less than or equal to 1, because cosine is between -1 and 1. Okay, so we can say that this quantity here is also less than or equal to 1 since they're equal. Okay, so we're almost there now. Just need to multiply both sides by absolute value of b minus a, and we have absolute value of sine b minus sine a is less than or equal to b minus a. Okay, next we got this word problem about a moving toy car along a track. Okay, position 5 meters apart. The velocity is measured twice. Show that the velocity of the toy car must have been 20 meters per minute at some point. So we'll start by letting f of f of t actually equal distance traveled as a function of time, in time t. Okay, so this function is going to be continuous and differentiable because there's no real instantaneous changes in distance or any jumps in distances. The graph of distance versus time is usually a polynomial or definitely continuous function. Okay, so by Rolle's theorem, or sorry, by MVT, first of all, let's set up a domain here. It says the whole thing lasts 15 seconds. So your time is goes from 0 to 0.25 minutes. So by MVT, there exists a time c in the open interval 0 to 0.25 such that f prime of c equals f of 0.25 minus f of 0 over 0.25 minus 0, which equals, so the distance at 0.25 seconds is 5, the distance here is 0 over 0.25, and that equals 20 meters per second. And remember, the derivative of this distance function is the velocity. So at some point that this thing was moving 20 meters per second. Okay, so next we're going to solve this problem where we have to find the smallest possible value of f of 7 by the mean value theorem. And we're going to assume it's continuous and differentiable on this interval. And by MVT, there exists some c in the open interval 2, 7, such that f prime of c equals f of 7 minus f of 2 over 7 minus 2. Okay, and so let's plug in the values. So f of 7, we don't know f of 7, that's what we're going to be solving for. F of 2 equals -4, and then on the denominator we have 5. And this equals f prime of c, and c is somewhere on this interval. So and it says here that the derivative is greater than or equal to negative 2. So we can say this whole thing is greater than or equal to negative 2. Okay, so we can solve this inequality. We have f of 7 plus 4 is greater than or equal to negative 10. So f of 7 is greater than or equal to negative 14. Okay, so in this question we're going to use Rolle's theorem to show that the derivative equals 0 has at least one solution on this interval. Okay, so this function is a sum of some cosines, so obviously it's continuous and differentiable. So f of x is continuous on 0 less than or equal to x less than or equal to 2 pi, and it is differentiable on 0 less than x less than 2 pi. Therefore, there exists c in the interval, the open interval 0 to 2 pi, such that f prime of c equals 0 by Rolle's theorem. Okay, so there exists at least one, and now hence we're going to find all the solutions. So the derivative f prime of c is going to be equal to negative 2 cosine 2c minus 2 sine c. So that should be a sign over here as well. So that equals negative 4. If I use the double angle identity, this is negative 4 sine c cosine c minus 2 sine c equals 0. Okay, let's divide both sides by negative 2 to make it look a bit nicer. And to solve this, we factor out sine c, and we have 2 cosine c plus 1 equals 0. So we have sine c equals 0, and we're going from 0 to 2 pi. Remember, by Rolle's theorem, actually I should say, oh yeah, it's on the open interval, so it's not including 0 and 2 pi. So sine c equals 0 when c equals pi on that interval. And here we have cosine c equals negative half. Okay, we're going to have a solution here and a solution here. We're talking about half. So we're talking about this triangle. And cosine, so that would be pi thirds in here and here. So we're going to get c equals 2 pi thirds and 4 pi thirds. So there are your 3 solutions. Okay, in this one we're going to use the mean value theorem to prove this inequality. And we're going to start by letting f of x equals root 1 plus x, where x is between 0 and h. Okay, so we know this is continuous, and well, let's write down f of x is continuous on 0 less than or equal to x less than or equal to h, right? And f of x is also differentiable on 0 less than x less than h. So maybe write by MVT, there exists c in the interval 0 to h such that f prime of c equals f of, and our boundaries are h and 0 over h minus 0. Okay, and over here I'm going to do the derivative of this at c is going to be 1 over 2 root 1 plus c. Okay, that equals f of h is going to be root 1 plus h. F of 0 is going to be 1 over h. Okay, so we're getting close to what we want. This should have been h, sorry. Okay, we want to solve now for 1 plus h, and then it will follow from there. So if I solve for that, I'm going to get 1, or h, I multiply both sides by h, I get h over 2 root 1 plus c plus 1 is equal to root 1 plus h. Okay, so this is almost looking like this. And we need an inequality here. Let me just rewrite this in this order. Okay, so notice that c is greater than 0. So this whole this denominator is going to be bigger than 2. So this whole quantity is going to be less than h over 2. So we have root 1 plus h is less than 1 plus h over 2.